Hello, in this video we're talking about solving absolute value inequalities. Inequalities are those greater than and less than symbols. Please take a moment and copy these rules as I'm talking about them. If the absolute value of A is greater than or equal to B, we're going to split it into an OR statement, whereas if it's less than, we're going to combine them with negative B is less than or equal to A, less than or equal to B. And then we have some other cases that we're going to just go through. So just pause the video and make sure that you've copied all these down. All right, the first case is if the absolute value of A is less than or equal to B, then we have negative B is less than or equal to A, less than or equal to B. But why? Why is this true? And we're going to look at the absolute value of X is less than or equal to 2 for an answer. What's important to remember, the absolute value is a distance. So the distance from 0 to this X is less than or equal to 2. All right, let's see what that looks like on a number line, knowing that the distance from 0 is less than or equal to 2. Well, this distance from 0 to 2, that's 2. And the distance from 0 to negative 2 is also 2. So all of these distances from 0 are in my solution. And written as an inequality, that would be negative 2 is less than or equal to x, less than or equal to 2. Which by this property above, if the absolute value of A is less than or equal to B, so the absolute value of X is less than or equal to 2, we can just change this 2 to a negative 2, is less than or equal to A, less than or equal to B, to 2. All right, so let's do an example. The very first thing that we have to see is that we have less than or equal to. As soon as I see less than or equal to, I know that I'm going to have two less than or equal to signs, and whatever is inside is going to go right inside of here, 3/4 x. Then I'm going to take whatever it's set equal to, like the 6 right here, and I'm going to put the 6 here, and I'm going to change the sign of that on the other side. Okay, so now we got to solve for x, and to do that we're going to solve from the inside out. So I got to get rid of this 3/4. To get rid of 3/4, you multiply by 4/3. Because that's going to cancel the 4s and the 3s. But whatever we do to this inside, we have to also do to each of these sides. Everything gets multiplied by 4/3. And there's two ways of looking at this. You can either say negative 6 times 4 is negative 24, divided by 3 is negative 8. Or you could also say negative 6 divided by 3 is 2 times 4 is also negative 8. Right now we just have x left in the middle, and it is less than or equal to 6 times 4 again was 24 divided by 3 is 8. Whenever you're solving absolute value inequalities, you have to put these things on a number line. So from negative 8 to 8, both of these things are included, and all of the x's, all of my solutions are between negative 8 and 8. Here's another way of looking at it. Just because you're so used to setting whatever is inside the absolute value bar to the opposite of this 6, well, we can still do that. We can totally start off with 3/4 x is less than or equal to 6, but with less than, we say and 3/4 x. Now here's the thing. We're going to not only change the negative 6, but we're going to change it to greater than or equal to. So we're going to change both signs. Now you go about solving these things the exact same way, just by multiplying those 6 and negative 6 by 4/3. And here we'd end up with x is less than or equal to 8 and x is greater than or equal to negative 8. Well, putting us less than or equal to 8 and greater than or equal to negative 8, that gives us the exact same graph. All right, now if absolute value of A is greater than B, then either A is greater than B or A is less than or equal to the opposite of B. So just the opposite of the example before it, the distance from 0 to x is greater than or equal to 5. So on a number line, the distance between 0 and x must be greater than or equal to 5. And so like the distance from 0 to negative 5 is 5. The distance from 0 to negative 6 is 6, right? We're getting greater than or equal to 5. And then the reason that this splits up into an OR statement, just like on this number line here, we can see that x is either less than or equal to negative 5 or x is greater than or equal to 5. So we either get the original back out or less than or equal to the opposite. Notice that both the signs change. This sign changes and the negative 5. So here, if we're looking at the absolute value of 2x plus 1 is greater than 7, I set up two inequalities. Either 2x plus 1 is indeed greater than 7, or 2x plus 1 is less than negative 7. Notice that both of these change. From here on out, it's just solving like normal. On the left side, we can just subtract 1 and then divide by 2 to get x is greater than 3, or after subtracting 1, we have 2x is less than negative 8, so we divide by 2, or x is less than negative 4. Okay, and now we need to see what that looks like on a number line. Now be careful to put your numbers in order, right? Even though they're written like this, the negative 4 is on the left. So all of these x's are either less than negative 4, and notice that this was not less than or equal to, or all the x's are greater than 3. All right, here we have the absolute value b is greater than or equal to a negative number. Well, yeah, the solution's all real numbers. An absolute value will always be greater than a negative number. In fact, absolute values are always greater than or equal to 0, right? That should make sense. Let's see what that looks like. After we subtract 5 from both sides, we get 3 times the absolute value of x is greater than 0. Divide by 3. The absolute value of x is greater than or equal to 0. Well, any x that I put in here would become positive. Even if I put a 0 in here, I'd get 0 is greater than or equal to 0, which is still true. So I could literally put any x in here possible. So my answer are all real numbers. And remember, on a number line, that just means that we're going to shade the whole thing. However, if the absolute value is less than or equal to a negative, that's not possible. There's no solution. If I'm taking this function right here and if I get the absolute value of 5x plus 1 is less than negative 2, remember that this absolute value, whatever's inside, gets turned positive. So this positive will never be less than negative 2. So here we have no possible solutions. And just like it said on the first page, the absolute value of a is strictly less than 0. That's also always going to be no solution. All right, that's it. Bye. Bye, 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 bye.